Good morning and welcome to the Risk Management and Infrastructure webinar, courtesy of the Institute of Risk Management. My name is Nicol. I am a Project Controls Manager for Turner & Townsend. By way of introduction, I have 13 years experience of risk management, mainly in the infrastructure sector, covering aviation, rail, energy, nuclear and utilities. I've worked for some of the biggest infrastructure clients, not only in the UK but internationally. And from this experience forms part of this presentation. In terms of the purpose of today's webinar, in short, this is a key summary presentation, picking up some of the key points from a wider two-day presentation or training that's being rolled out with the Institute of Risk Management in Turner & Townsend next month. But the purpose of today's webinar is to discuss how an effective and dynamic risk management framework is vital for the successful delivery of large projects, programs or portfolios within infrastructure, capital, asset delivery environments. What we'll also talk around is around the benefits of risk management, communicating these to not only clients, employees, delivery partners, or stakeholders. We'll also touch on the assessment of risk, not only being qualitative, semi-qualitative, and then quantitative. We'll also have a quick discussion on techniques, and then also challenging around QSRA, which is a hot topic in infrastructure projects at present. All of which this should help inform decision making that aligns to the organisation's risk culture. So what we will finish up on, depending on time, will be around dashboards and risk reporting and getting the right messages across, because very often with the tools and techniques and risk databases that are available on infrastructure projects, is that the right information is still not getting fed up to senior management to make the right decisions. All right. So just as a way of introducing the topic, I guess, risk management and infrastructure projects. So infrastructure projects, how I would describe them are I guess, anything that isn't kind of building straight up there. So infrastructure covers anything from rail to roads to aviation to power, energy, oil and gas, those sort of projects. In terms of what happens when you don't manage risk, there are historical challenges or examples of projects that have gone historically wrong. This is not to say they didn't have risk management processes in place, but there were key decisions that were made or missed that caused significant overrun. And I guess, as you will see on the slides, we've got the Scottish Parliament, which went from 40 million to somewhere in the 400 million, Wembley, which doubled in price and had significant delays, and then Channel Tunnel, which went from 4.8 billion to 12 billion. There are a whole host of other examples. There's London Underground PPP framework in the late 2000s, which significantly overran in terms of cost, and even, I guess, Crossrail and the likes, as you can see, or you may know in terms of delays that they are currently suffering. So what are the key challenges, I guess, behind that? And I guess one point to pick up here is that consistently within civil engineering projects, optimism bias rules in terms of overrun. So looking at this table, and albeit it is a few years old, this non-standard civil engineering projects have a percentage overrun of somewhere in the region of 66%. That's a staggering number. And looking at the table below, you can see that rail projects in the past, still currently, are overrunning significantly more than other projects. And we'll touch on a little bit as we go through in terms of estimating uncertainty and program estimating and program duration uncertainty, is that optimism bias is still key within infrastructure. Projects, clients, delivery partners all believe that they can deliver projects earlier, faster, cheaper, and then the outturns turn out to be something somewhat different. So what are the sort of challenges infrastructure projects are facing? So according to the National Audit Office, there are several key areas for project failure. Unclear objectives. So what is the project setting out to do? Is the scope fully defined? Often within infrastructure projects, there's a large change of scope or development of scope as a project progresses from concept through to design through to implementation. Is the right team in place? Have they been adequately trained? Poor or no planning? Are there unrealistic timescales, ineffective controls in place? And then poor communications, lack of stakeholder consultation. So in terms of infrastructure projects, you have a large amount of clients and key stakeholders that have an interest in the project. It's key to understand what are their key drivers, how do you communicate to these stakeholders to ensure that they are on board and fully bought into the risk management process. Other risk challenges that we've been seeing in industry. I won't run through all of these, but there's several wide varying risk challenges. So anything from poor project change and design management to the risk management process not only being seen as a tick box exercise. There's also poor collaboration, a lack of trust. So it's getting better in terms of infrastructure. There's a lot more alliances and collaborative ways of working, but there are still, I guess, a lack of trust around contracting organisations, which is, in my view, slightly wrong, where these are the people that have the expertise in terms of delivering and building these projects. Other key points to pick up there is around appreciation of handover and commissioning. Very often in infrastructure projects, you get to the end of the job and you've used up your time just trying to deliver rather than handing over and commissioning appropriately. I guess for those in viewing or listening into this webinar, are there any of these, I guess just a quick question, are there any of these risk challenges that you see facing yourself, either on your projects or within an industry that you are working in? Or just a comment to think about? So what have I talked about? I've talked around projects that go wrong and challenges. I guess there are other areas or other infrastructure projects that have been successful. So we've had the London Olympics. In recent years, it was delivered on time and on budget. And previously, we've had the DLR in London again, which was delivered on time and on budget. What are the key aspects then that are driving successful risk programs for these infrastructure projects? So the next slide tried to summarise some of the key points to consider within the terms of a successful risk programme or for a project process. And we'll touch on these as we go through. Firstly, you've got to define objectives. And this is not just project objectives, it's around the objectives for the risk process itself. Often you find the risk register or risks that are identified are not aligned to the project objectives. So it's also key to understand from the outset what are your project objectives, what are the drivers. In simple terms, is it cost, time or quality? But are there other aspects that are driving a client and a project to delivery and success? Understand the exposure is the next aspect to consider in successful risk programs. So going back to that optimism, there has to be a challenge and counteract the bias. A lot of it is challenging hindsight and optimism, and there's an illusion of control, i.e. people believe that they can control their risk exposure and often underestimate this aspect. So there's key to challenge and probe this bias. We'll touch on another aspect, which is talking around working back from key milestones. A key technique that we utilise in infrastructure projects is pre-mortems, as we call them. Basically assuming that, or putting ourselves forward in the project and looking back on what are going to be the challenges to make us meet these milestones and what are the risks that we may face. This allows for more proactive planning It allows for resequence of schedules, and then also looking at proactive mitigations that can enable projects to meet their key milestones. The next aspect that we would consider is prioritising the risk strategy. I would always be a keen advocate of quality over quantity. All too often you see on projects 300-400 risks on a risk register and minimal smart mitigations. We'll touch on it again a little bit later on, but the key aspect in any successful risk process is to focus finite efforts where they are needed most and understand where you can actually influence and mitigate risk or realise opportunities. All too often on project risk registers you see things like weather risk on a risk register. While it may be a risk to the project, there's very minimal that can be done in terms of mitigating that risk. What I advocate is the looking at where you can influence risk, and these are the risks that should be flagged as mitigations need to be tracked and management decisions need to be made. And then the final aspect is executing and learning. All too often the same mistakes happen on infrastructure projects. So the key to any successful risk programme is around continuous learnings and involvement. And I'll talk about it a little bit more, but lessons learned typically happen at the end of a job. They shouldn't happen at the end of the job. They should be happening throughout the project life cycle at key milestones or key stop points, and those lessons learned either fed back not only to the project but back to a client and back into other projects. Okay. So what we're now going to talk around is then just around the setup and then the process on infrastructure projects. So I guess taking a standard risk management process, the first aspect is around understanding the risk strategy and the initiation stage. And as said on the previous slide, it's key to understand what are your client or the project drivers. All too often people think that they can satisfy all three, but in all honesty, one will always be the key driver. And from this, that will then set the tone in terms of your risk culture and your risk process. So i.e. if a project, say for example, a rail project needs to come online on May 2020, that is probably going to be the key driver, and cost and quality will be the secondary drivers behind to support those drivers. It's key to understand from the outset what your client or project's drivers are, and then how that then frames your risk process going forward. So what that can do, i.e. where there's cost drivers, is you probably would start to focus more on cost QRA and certainty around cost. With the schedule drivers, you would be focusing predominantly on certainty through quantitative schedule risk analysis and hitting milestones or providing confidence in meeting milestones. From that sort of sets the benchmark of what the expectations of the risk process will be going forward. At the early stage of any project, it's key to develop a successful or set out a risk framework for successful delivery going forward. That it is not a one-size-fits-all. Often you see risk management plans, procedures that have been incorporated from previous projects. I would strongly disagree against this, because in every project there's different drivers, as mentioned. There's different complexity challenges, there's different size and schedule, there's even novelty challenges. And with this comes a need to develop a risk framework that captures some of these key points as highlighted on the slide. So something around the scope of service and relationship that the project may have with portfolios, programs, and the enterprise risk management frameworks. It's critical to have clear roles and associated responsibilities, not only the risk process, but then the parallel processes. So in terms of developing the project schedule, developing the project cost estimate and the documents, it is key to understand who is responsible for the development of these documents. Classification schemes to be used to assess the severity of risk. This can be simple probability impact assessments and cost and the schedule, but then it can also be around reputation. It can also be where we've seen some infrastructure projects where it is in a live working environment. So there will be aspects in terms of operability impacts or outage impacts. Again, this goes back to key project drivers. Other aspects to consider when developing a successful risk framework is understand the level of risk that can be tolerated. This can often be found in a risk appetite statement, but then within your project, your PID, your probability and impact diagram, there will likely be a level of tolerance that you will be working to reduce your risk to, in simple terms, red down to green or amber in between. Rules for escalation. What we've started to find within infrastructure projects is previously they can only manage risks within their project bubble. There are risks out with their control, either at program level, enterprise level, portfolio level, that they cannot manage, that need to be escalated to other levels within the organisation to manage that risk. If those risks are not mitigated, they can have an impact, a negative impact on the project going forward. Confirmation of tools and techniques. It's from the outset, it's good to set out what the intentions are, not only just in terms of the risk review process or identification process, but then also the tools that will be expected to be used going forward in an infrastructure project. We'll touch around these QRA tools later on, but then there's also other risk databases that we see, the likes of Active Risk Manager, Exactium, Predict, etc., are other tools that are used in infrastructure projects. Confirmation of reporting cycles and information requirements. Key. Typically, they are done on a monthly basis. I've seen it in some circumstances where it's done weekly or even daily in terms of risk when construction is out on site, and it's key to understand what are our key exposures. Talk around project contingency management and how this will be drawn down. Very often, change control is a key critical aspect to an infrastructure project and the success of an infrastructure project. And then templates. It is critical from the outset to set expectations of what everyone will work to in terms of risk management templates, not only be it in risk registers, dashboards, but also exec summaries and QRA reports. This enables comparison and apples for apples comparison. Okay. At the very outset and then throughout a project life cycle, infrastructure projects are subject to gated processes. Now, these processes allow clients to get a confidence around the development of a project. It allows delivery partners to provide confidence and assurance around their ability to deliver the project, and again, it ties into stakeholders and their requirements that the project's benefits will be delivered at the right time and on budget. I won't go through all the stages, but I'll leave it on the screen for you to look at. I guess the key is to consider here is that a gated process on an infrastructure project or on any project should be seen as the ability to challenge the project as it progresses, but then also to have serious and supportive conversations in relation to whether the project should proceed or not, i.e. go or no go. I think there are examples of projects that have proceeded that maybe should have been stopped before construction. I think there was a quote around the Channel Tunnel not delivering the benefits that it set out to do, and that it was able to have been stopped earlier than it could have done, and that would have stopped a significant cost overrun. In terms of risk management throughout this gated process, it plays an important role. So at the early stages of initiate a project or project execution, you can see risk management forming part of optioneering or scenario analysis to enable what is the best route forward. And again, this will be linked back into your project drivers. I guess as you are heading towards project execution and final investment decision, risk management can develop contingency allowances, both in cost and in time-related allowances. Then in delivery, risk management process will enable or demonstrate potential risk exposure reduction, and then opportunity realisation. And then at the very end, close out. The risk process will highlight residual risks, either hand over to operations or just to be residual risks accepted by the client. Throughout this process, again, lessons learnt is key. So I'm a strong supporter at each stage to have a lessons learnt aspect review. This not only captures risks, opportunities, issues, assumptions, it can capture mitigations that worked, mitigations that didn't work, and then general ways of working that could improve how a project progresses. Now, risk management across the project lifecycle. It's a pretty basic slide, but it's fundamental in terms of the effectiveness of risk management across an infrastructure project lifecycle. Risk can be much better managed at the earlier stages of the projects with design. Design changes or key decisions can be made to avoid or mitigate risk or enable a project. Again, it is linked to the GATE process, where clients and organisations are looking to demonstrate a reduction of risk exposure as it progresses through the life cycle stages. I guess the key point to note on this slide is when you're in the construction phase and risks are happening, you're typically in a firefighting reactive stage rather than a proactive mitigation and avoiding stage. Following a general risk management process, we'll then talk around risk identification. Now, some of these are quite standard and obvious, but I'll touch on some of the key examples within infrastructure projects that may be key to be picking up. Typical risk identification techniques form around risk workshops, people bringing, or SMEs bringing expertise and experience to the table, lessons learnt logs from previous jobs, historic project risk logs, checklist prompts, which we'll touch on a little bit in the next slide, and then project plans, design reviews, project documentation, approval gates, and business cases. How are these done? Typically, they're done in general risk workshop environments, brainstorming, interviews, SWOT analysis, PESTEL, but we'll also pick up again on the next slide in terms of risk breakdown structure. But one other key aspect, as I've touched on, is around scenario analysis. Very often, infrastructure projects are complex in nature. They are also bespoke in nature. Sometimes they are novel, never been done before. So scenario analysis often plays a key part in the identification of prominent risks that the project may face. And by this, scenario analysis can be forward-looking, i.e., what's it going to take to get us to that milestone or to that achievement, or as mentioned before, heading forward to the key milestones and visualising what are the challenges we're going to face and looking back on ourselves. What this does is it enables, again, proactive mitigations. It allows for triggers to be placed within, not only within the risk management process for when mitigations have to take place, but then also when key decisions have to take place within the project schedule. All too often, key decisions are missed or they're made late because they haven't been planned out properly. Doing these techniques, scenario analysis enables a project to look ahead and form the right building blocks to make the key decisions in a timely manner that then enables the project to progress at the pace it needs. As mentioned, risk breakdown structure, they're becoming more and more common within infrastructure projects. I first saw one on London Underground about 6-7 years ago. Again, they can be bespoke, but typically the I'll just show the examples. They tend to form around key aspects of a project lifecycle, so consents, design, interfaces, procurement, site conditions, delivery, and external influences are some of the key ones that typically continually appear on a risk breakdown structure. The benefits of a risk breakdown structure: not only does it assist with understanding of the nature of risks and allows for associated root causes to be identified, it is also a vital tool as it helps to benchmark a project in terms of considering all possible risks, i.e. after risk identification processes, you could see that there's more risks identified in design than there is in consents, and then the challenge would then be, have we considered all our consent risks, or are we actually mitigating and managing that properly? What it also does, conversely to that, is it allows, again, it focuses senior management or project management on the key areas that have the highest number or the greatest risk exposure. So the benefit of risk breakdown structures is not only just around identification and checking we've identified anything, it then allows for the breaking down of the scope of a project and understanding where the risk exposure lies. Throughout not only the identification process, which is the point of this slide, but also throughout the project lifecycle, it's key to understand different aspects or different processes that link into risk. And I've split out opportunity just to highlight here, but typically opportunities is part of the risk process where you're considering threats and opportunities. But when you come to opportunity management, it's key that that you report opportunities formally only when they are very likely. Within projects, you can see a high volume of opportunities that are identified that are not feasible and that will not ever be realised. There's a slightly different mentality to opportunities to risk, threats in that instance, so we recommend using dedicated opportunity workshops to campaign to improve opportunity harvest. So in my current client, we have specifically set out a whole series of opportunity workshops, and it is linked to value engineering and value management, but it's also just looking at more efficient ways of working, and it's challenging norms and scope, etc., that may have been in place for many years or done before, but it's always asking the question, is there a better way of doing this? In terms of the last point on opportunities, beware of using weak opportunities to net off the collective exposure of more certain and better understood risks. Very often within risk modelling, opportunities can be built in to reduce the risk exposure. What I would advocate is that opportunities and threats and risks are modelled separately, so that an honest and open discussion can be had as to what the risk exposure is and what the opportunity potential is, and compare them against each other rather than the opportunity exposure or realisation diluting the risk exposure. Tying back into the project lifecycle and the development of risk management throughout that, a project will typically develop and mature in scope and estimate and schedule, and it's key throughout this development that a number of assumptions are captured. So key decisions will be made in design assumptions, cost assumptions, planning assumptions, and from this may trigger risks where an assumption, a key assumption that allows for scope and design to progress may not be stable, may be quite sensitive to change. What we would typically advocate there is then that a similar risk or a risk capturing that potential for that assumption to change is captured within the project risk register. And then the other part to consider throughout a project life cycle and linked to risk is around issues management, issues and trend management. So in construction sector, issues are normally received as risks that have occurred and require immediate senior management to resolve to avoid incurring a material adverse impact on the project outcomes. When interpreted in this manner, a project manager is the responsible party for managing the issue register. what is key there is not only the management of issues, but then by properly managing and mitigating issues, it prevents them happening again in one other shape or form. All too often, a risk happens on a risk register and then is transferred to the issues register, but then is not appropriately mitigated, and then that same risk then happens at a later project life cycle. So what is key is to capture the issue as it has happened, but then also entail to ensure that the risk or the root cause is mitigated, does not happen again. So we move into assessment, and now this will touch on a few points, and a couple of slides may be a bit general risk management. But in terms of infrastructure projects, very typically, most projects will have a likelihood, an impact, or probability consequence, however the terminology is on projects, that then allow for initial scoring of risk. Now, this is my point of initial scoring for risk is that red, amber, green, or 5x5 only provides a flag to management as to what are the key risks to manage. It doesn't, in my view, give a clear understanding of what the potential impact of that risk is. What it does in the first instance is it helps to prioritise efforts and attention around risk. So just running through it, typically we've got a 5x5, so it could go anywhere from rare to almost certain in certain probability ranges. And then down below, as mentioned before, you can have it in terms of CapEx. We've also seen OpEx impacts, or even TOTEX in some aspects, where the project is seen as not only just delivering a capital project, but then also running into operations for several years. We've also seen reputation, health and safety, and environment as key aspects on which to score risk. What I haven't got is a slide that will show the red, amber, green and the tolerability, but you may be familiar with them in terms of PIDs, or probability and impact diagrams. So where I was coming from there is the likelihood and impact assessment allows for understanding the initial exposure of a risk. There are other aspects within infrastructure projects that we would recommend are used to prioritise risks. And I've just flashed them up on the slide. So a typical one is proximity of risk occurrence. So in infrastructure projects, it can range from a couple of years in terms of delivery up to 7 or 8 or even longer. So it's key to prioritise efforts, in my view, in terms of what are our most immediate risks, what are our most forthcoming risks. A commissioning risk 5 years down the line may need to be thought about now, but ultimately it should be, I guess, a design risk that's happening here now. And one other aspect I would want to pick up on this slide would be around controllability and ability to influence. So as previously mentioned, risk dashboards and risk reports often don't utilise their ability to request an action or a decision by management. If we are able to influence and manage a risk, it should be prioritised and then obviously escalated to the appropriate level to make the right decisions to influence or enable mitigations to happen. These are aspects to prioritise risk above just simply probability and impact. So moving on from qualitative assessment, and we've kind of touched on, what is your third dimension? I guess it's just a takeaway is what other aspects would you consider in terms of prioritising risk aside from probability and impact. So moving on, quantitative risk assessment continues to be core in terms of successful, infrastructure risk management processes. It helps to focus senior management attention on priority areas, both in cost and schedule, or even collectively in an integrated model. It helps to quantify a project's likely outturn cost or completion date, and consequently inform monetary and time allowance contingencies. It is a more efficient way in responding to risk by balancing reduction in exposure against the cost of control. So what quantitative risk assessment can do is put or give an understanding of the cost impact of a risk, and then you could compare that to the cost of mitigation, i.e. if a mitigation or the key mitigation for a risk is higher than the impact or the potential impact of the risk, the question would be, is it worthwhile pursuing that mitigation for that risk, or do you just accept that risk? So those sort of questions that the QRA aspect helps to inform a project. It helps to understand the combined impact of identified risk on a project program, and it helps incorporate the effect of correlated risk items. And what we'll do in terms of the follow-on slides, we'll touch on the QRA process and infrastructure. Just a reminder, I guess, the 2-day risk training course that is being rolled out next month and then followed ongoing, will touch in a lot more detail in terms of the key things to look out for, the steps, the tools and techniques that are required to successfully run QRA that provides benefit to projects. You often find on infrastructure projects that a QRA or a QSRA is asked for as more of a health check rather than an informant. They're very powerful tools if used in the right way to identify where the biggest exposure or uncertainty lies within a project and where best to focus resources and effort. So just in summary or highlight terminology, so QSRA is quantitative schedule risk analysis. Typical tools are Primavera risk analysis, which seems to be the industry standard, but we do see Safran, Deltec, Acumen Fuse and At Risk being used elsewhere. QCRA is quantitative cost risk analysis, and again we'll run through the basics or the key aspects of these techniques in a minute. Typically used in At Risk and Predict, but I've also started to see it used within Primavera risk analysis as resource loaded or cost loaded schedules are now being risked. And then, as mentioned before, you tend to see risk registers, risk databases. I'd question the benefits of these. They are good for capturing risk, but in terms of QRA techniques, the likes of ARM and Exactium are not strong, and then you still tend to use the tools as previously mentioned. So risk quantification. Now, before we dive into the nuts and bolts, so to speak, but I'm not going to go into that much detail. It's key that a project team reviews and make assessments on the main sources of uncertainty to an infrastructure project delivery. Some failings you find on projects is they only consider one or two of these aspects. What we recommend is assessments on uncertainty. So when we talk around uncertainty, we're talking around a project cost plan, cost estimate as it develops through the project life cycle, and the uncertainty in terms of delivering that estimate. So typically you'll see, at a very high level, you could have procurement of steel as an aspect within your cost estimate. There may be a plus or minus aspect to that value. So say it could cost 1 million, it could potentially be delivered cheaper at 900k, or based on past experience, it could go up to 120k. Also within uncertainty, we look within the project schedule, and we'll talk around it in terms of the tools and techniques in a bit, but uncertainty around durations. So similarly to the cost plan, but you put uncertainty around the ability to deliver an activity. So concrete pour, for example, could take 100 days, could be delivered quicker than 90, or could overrun and take 110. By doing this, you build up a picture of where your uncertainty lies within your cost plan and your schedule. Again, when you run this through the model, you're able to understand where these biggest levels of uncertainty lie. This then enables mitigations to mitigate and reduce these exposures going forward as the project progresses. So cost of schedule delay is another aspect we would consider in terms of complete risk exposure. So this is just a summary slide, but once we run through the QSRA aspect, the expected delay can then be monetised as potential risk exposure, and then also the delay duration can be built into a schedule at time risk allowance. Discrete risks, again, these are modelled either in cost impact or in schedule. So in schedule impact, they can be mapped against activities within the schedule. So again, using concrete pour as an example, if there's a risk of poor quality of concrete from a contractor, that sort of risk can be modelled on those activities. That would then have an impact or a knock-on impact on that schedule in the model. And then on known unknowns, typically after doing all these steps within the complete risk exposure, there is still an aspect or a discussion to be had around management reserve or unknown unknowns, because key to consider within these tools and techniques is that it's a snapshot in time, and it's using the best available information. There are risks that will come out left side that the project is not thought about. So it's key the client's organisation and management are considering holding reserve aside for new risks that may be identified and require mitigated. Okay, moving on, quickly we'll run through the process for quantitative schedule risk analysis. So in simple terms, and as talked about there, you take your schedule, and apologies for the slow moving of this slide. You take so a typical high-level schedule, 4 activities. What you then do would then put uncertainty around those activities where you felt uncertain. So you see in this example, activity 4 doesn't have any uncertainty around it. That may be, typically you tend to find review periods. So set approval periods, maybe 20 days or a month. They tend not to have uncertainty around them. And as said before, it can be negative and positive, not only negative. So, and as you'll see in activity 1 and 3, there's potential for that activity to be delivered early. What that means is if you were then to run that model, it will give a confidence level that you might be able to deliver early, but as this has been set up in the way it has, there is more chance that the activities will overrun and the confidence levels will be lower. The other aspect as mentioned is around adding risk and or opportunity. So as said, you can map risks or opportunities directly to activities within the plan, which then enables, again, understand where, I've seen that question, I'll answer that one at the end around unknown unknowns. So mapping risks and opportunities enable, again, project to understand key sensitivities, key areas where they may want to resequence risk activities, key areas where float may want to be built in or time risk allowance may be built in to enable projects or activities to meet their milestones. So diving into the QSRA process, and this is I'll keep this as high level at the moment as possible because it can be quite laborious, but I've kind of kept it to 5 key areas. This is a continuous process, mind you, so it continually happens. On infrastructure projects, going back to the gated process, you would typically run QSRAs leading up to the key gates to inform confidence in the ability to deliver. On recent infrastructure projects, some in rail and some in nuclear, quarterly QSRAs are now happening as part of confidence levels to not only the project team, but then program and portfolio level and the ability of the project to hit its key milestones and deliver. What it's doing is providing confidence or assurance around the delivery partner's ability to deliver. What it can do is flag up areas of concern, and what it's been seen as is an early flag to then enable what mitigations need to be put in place. So running through the process, I won't go into too much detail, but it's key that the programme is a baseline schedule received from the planning or the planning team for the QSRA. There are differing views, but in terms of the level of detail within the schedule, I would always be looking for a slightly rolled up or a higher level programme to use the QSRA on. or to manipulate the QSRA on. Somewhere in the region of 1,000 to 2,000 activities is typical. Anything in the 10,000 activities plus adds in unnecessary detail that then allows for a model that may not be realistic. From that, you then challenge the integrity of the schedule. So within PRA, but then also other tools, there's a schedule check tool. This we'll touch on it in the next slide, but this is around making sure that the schedule doesn't have any unnecessary constraints in it, that it's logically linked, lags are reduced where possible, and open-ended activities. This enables the model to model, apologies for repeating that again, but to model uncertainty and risk both negatively and positive. When there's constraints in there, it doesn't model fluidly and can have a negative impact on the results, i.e. it knocks the model further out than realistically. The next stage is then around a series of QSRA workshops. They, firstly, as mentioned, will focus on duration uncertainty in the schedule. So again, taking a concrete pour example, there will then be separate workshops around mapping risk to activities. Key not to overload certain activities with risk. And it's key to also understand what's been accounted for in duration uncertainty. Typically, you can see double dipping happen and a negative impact put on the model. From the workshops, you then follow it down to middle left, let's say, and then you develop the QSRA model and perform risk analysis. This is a very simplified version, as models very rarely are ready to present to management after run one. There are typical challenges or areas within the schedule or the risk model that need to be ironed out before presenting. So you typically find that the process through several iterations and challenges requires to test and agree logic, the mapping of risk, the mapping of DU, and again going back to double dipping. The analyse results and then the presenting of results is in the final part of the process. As said, it enables management to highlight, or enables to highlight to management potential impacts, sensitivities within their schedule, but also it enables scenario analysis and what if modelling to happen. So recently on a current project, we've been modelling flight delays that are slightly left field, but are potentially going to or could happen. And what it's done is enabled the project to start thinking about what it can do to mitigate these risks as early as possible. And so what it does is it flags the sensitive activities, it sends key risks to mitigate. And then I guess, and that's the key, it's around the mitigation. So very often around the outputs of a QSRA is that it will tell you P numbers or confidence numbers in terms of hitting key dates and tornado graphs around the risks and activities. The key, a fundamental part that is missing is then the what next in terms of mitigations, and that is the powerful part of QSRAs. Okay, moving on, just conscious of time. So as said around schedule requirements for QSRAs, we talked around the logically linked. There are tools, Acumen Fuse, Deltek, or the likes that flag up very quickly what the baseline schedule is saying and whether it is fit for modelling. This is an activity that is often overlooked in terms of the risk manager and the planner, and it's key to get a logically linked schedule or one that is fit for purpose for a QSRA, pardon me. So this is removing constraints, as said, removing incomplete or out of sequence logic, and removing any lags and open-ended tasks. Key things to consider when modelling. I won't go through them all, but it's just more as points and considerations. What are the appropriate distributions? It doesn't always have to be triangular 3-point estimates. Correlations of inputs. So when we talk around correlation, things around demand and price, weather impact and season, selling price and competitors, load, material load and fatigue are stuff that you can correlate, should be correlating or considering correlating within your QRA models. Modelling multiple occurrences of risk. These tools and techniques are typically set up to model risk once. very often within infrastructure projects, the same risk continues to happen in one shape or form. So it's always key to consider when modelling risk is how is it being modelled in a multiple aspect. Other points to consider is calendars. In a multi-phase infrastructure project, say where you've got design, procurement, construction and commissioning, these aspects will likely be working to different calendars, i.e. 8-hour days, 12-hour days, different shifts, etc., 5 days, 7 days. It's key to, in the base schedule, what is built into the model is to understand what calendars are being pulled through and to challenge and make sure that this is the correct information. And similarly, this is around, can be applied to rate cards and resource loading. Is that when loaded, a cost loaded or a resource loaded schedule is built into the model, it is key to challenge and consider, are the resource required loading correct and the rate cards correct. So as mentioned, the outputs are typically tornado graphs, bell curves as well, but what also, and apologies for the poor quality of this slide, is we're seeing more and more clients want to understand what the shift is from their base, whether it be from P to P50 to P80, etc. And the distribution analyzer is a key tool in that sense. And that said, we investigate more of this in training, training going forward. But other key outputs to consider, typically people will ask P50, P80, P90, outturn confidence. What we're now starting to have conversations around is understanding what's the range between P50 and P100 or P50 and P90. This enables clients and projects to understand what is the range of our potential exposure and do we want to be managing that range or the top end of that range to mitigate it down. Other aspects to consider is around criticality, so not only critical path but also critical risks and impact on activities, and then also cruciality. This is something that keeps coming up in infrastructure projects where they don't have one critical path, where there are multiple critical paths. It's key then to dive into understanding what are the most crucial activities. These tools provide that sort of outputs and again enables and focuses attention on what are the critical and crucial activities and risks to focus on. Okay, moving on. Oh, no, it's not moving on. Just one more aspect is around QSRA level of service. QSRA techniques is not always one size fits all. So some learnings we've been seeing in industry is that some projects are not ready for QSRA or are not at the right level of maturity. So it's always key to understand what level of maturity you're at. It's the age-old adage, rubbish in, rubbish out, can have a negative impact on the modelling. Novel design and technology, project complexity, commercial aspects are key other aspects to consider when applying a QSRA. It's what is the benefit and why are we doing it? It's not, as I said, a one-size-fits-all. So it's key to understand what it's being done for and for what reason. Want to quickly touch on quantitative cost risk analysis. So again, I'll pull up the onion, so to speak, or the different levels of complete risk exposure. So what I've just run through is the schedule aspect. So say, for example, we've run the QSRA and it's saying there's a delay of 2 months. What you could then do within your cost modelling would build that 2 month delay or monetize that 2 month delay. So that may be, in some instances, be taken by peak labour rates or when there's most people on the job, or by material rates, etc., etc. What it does is help to build a more rounder or complete risk exposure. So here it's always key to look at integration. So the integration across from uncertainty to cost of schedule delay into discrete risk and unknown unknowns. And I'll try and answer the question that's been raised. So any suggestion on informing the unknown unknown proportion of the overall risk exposure? Typically, we've been seeing uplifts. So you would do your uncertainty, your cost of schedule delay, your discrete risk, and you would come to a number, say, for example, 100 million. We're now seeing, say, example, anywhere between 5 and 10% of that being earmarked or set aside at a management reserve level, not being held at project level, but being ring-fenced apart from that for them future unknown risks. It is then when the project have identified these unknowns, they then go to management level, program level to then draw down on this management reserve. So it's not given to the project, it's for the project to demonstrate that they've either identified the risk or they need to pay for mitigations, so to speak. Hope that answered it, let me know if not. So just quickly running through the cost. And it's a very similar slide to before, but it's more around the uncertainty in the cost plan. So earlier in the project, there's higher levels of uncertainty in a cost estimate when scope is undefined and the project is developing and maturing. So starting in the decision to proceed and feasibility stages, you tend to see the funnel of the estimate much larger, and then as the project progresses, the cost estimate baseline in the middle, the black dotted line, you'll start to see the base estimate grow as the project becomes more certain. So uncertainty becomes scope. So the estimate tends to grow over time as risks are realised or new scope is found or mitigations are put in place to mitigate certain risks. And again, this is something that can be linked to the gate process, as it is key to freeze scope, schedule estimates and risk exposure at certain stages so that key decisions and investment decisions can be made before proceeding to construction, which is, I guess, the final point before a project can be stopped. So I've quickly touched on estimating uncertainty within the cost estimate, and what I just wanted to quickly show here was around some of the tools and techniques. Very simple, but quite very effective. It can be used. So within a cost plan, a typical cost plan, you can break it down in terms of quantity, schedule, and rates. And then to the far right, there are percentages on those rates, those quantities, those schedules, that then very quickly enable you to see where the biggest uncertainty within that cost plan is. Then the next question would be, what are we going to do around that uncertainty? So typical mitigations for that is placing off contracts or securing estimates from the supply chain. It then also allows potential EU or estimated uncertainty allowances to be built in to the model. Other aspects in terms of the cost, I guess just to touch on the discrete risk, so you'd have your cost risk or your discrete risk register, which would be modelling cost impacts only. This is where you could also model your schedule delay in a monetised. And typical outputs are very similar in terms of expected outturns, SRs, and then tornadoes. Again, where most benefit is found is where the tornadoes would be an area to focus mitigations on and reducing that exposure going forward, which will quickly touch on, conscious of time and overrunning here. So the next area is risk responses. All too often in the past however many years, 13 years, risk mitigations are often overlooked, and I kind of touched on it earlier on in terms of quality versus quantity. There's a tendency for projects to identify hundreds of risks and do very little about it. All too often projects firefight to manage risks once they've occurred and become issues rather than manage them proactively. Quick image there is around being proactive and not reactive. Risk happens slowly at first and then all at once. Try and be forward-looking. Try and be proactive around it. It can be difficult in a fast-paced, complex infrastructure project, but having those decision triggers, when do we need to know, when do we need to have a decision on this mitigation that then enables the project to proceed without delay, are key questions we often ask. And then touching on the quality over quantity aspect, as I'm an advocate of Pareto 80-20. it's key to understand. Now, this is obviously not guaranteed throughout every project, but typically 80% of the risk exposure on most risk registers will be found within the top 20% of that risk register. Again, tying into what I said before, this should be linked to risks that can be influenced and mitigated by the project. If the project cannot mitigate or influence the risk, I would focus attention on other risks that can be mitigated and managed. This enables a realistic risk exposure to be reduced over the time of a project. Anything else? Yeah, the focus should be on risks, the best place to manage and ultimately reduce or eliminate. Now, this is again going slightly into generic risk space, but it's also key to understand risk versus reward, as mentioned before, and what is the project's mentality or decision making in terms of plan response strategies. So typical ones are avoid, mitigate, transfer, and accept. One aspect to consider here is that by transferring a risk to a subcontractor or to a contractor, ultimately doesn't remove the risk from the client if it's badly managed by a contractor or a subcontractor. That's a key point to consider. We often stress to clients is that it's ultimately their risk, and how they enforce a strategy or enable a strategy will still mean they've got to manage the risk somehow. Risk response plans must be cost effective. So as said, risk versus reward. If the mitigation is not realistic in terms of cost saving or schedule saving compared to what the risk impact is, then why proceed with that mitigation? They should be smart. They should have clear, measurable actions that are not business as usual. We typically see recruitment or day job as mitigations which aren't right. They should have an action owner and have a clear target completion date. All too often, ongoing as a mitigation date is not suitable and often sees that mitigation slip in terms of progressing. And then the fundamental rule, as said, it should be borne by that a risk should be borne by the party best able to influence and control it. There is no point having a risk owner who is not best positioned to manage that risk. All right, moving into the final few slides. So as said, dashboard and reporting is key. I'm an advocate of not just reporting on what the top 5 risks are. So this should tie back into the prioritisation of risks, whether it be around variability, uncertainty, proximity, risk occurrence, urgency of required response, and controllability and ability to influence. So what I've shown there is just very quickly dashboards and waterfall charts, but what typically I would use a risk report for is a decision. In a past life working for a contractor, Lang & Rock, our risk reports highlighted where they were, risks they were able to influence and mitigate and when they needed to do it. It was more very simplistic at senior level in terms of what's the risk, what needs to be done, and when does it need to be done by. And what that did is it focused attention. By putting 100 risk register in front of management, it's very difficult for them to work out what they're being told and what they need to be doing. So in terms of risk reporting, it's key to tailor the report to the end user. Don't just press a button on a database. Don't just pull the top 5 risks out and pull it in there. Pull through the risks that either are deteriorating or need action, or the ones that need mitigation enabled to then progress and reduce that exposure going forward. And then that is very quickly a run through in terms of risk management and infrastructure. As said, this is a summary presentation of a much wider training that's going to be rolled out, and there'll be a lot more detail around that potentially could be done as a webinar once we've started rolling that training out. In terms of benefits of risk management of infrastructure on projects, taking from the PRAM guide, it enables better informed and more believable plans, schedules and budgets. It increases the likelihood of a project adhering to its schedule and its budgets. slide's not working, sorry. Allows for a more meaningful assessment of contingencies, typically on infrastructure, or not typically. In past life, you would see a 10% figure applied with minimal backing up of information. What these tools and techniques that I've talked around provides is a realistic view of the risk exposure at that point in time, and then enables decisions to be made rather than, we'll just whack 10% on the bottom line and hope that that's a risk pot going forward. It contributes to the build-up of statistical information to assist in better management of future projects. So as I said, the lessons learned is key throughout. So where risks occur or risks are mitigated, mitigations are successful, mitigations are not successful, that sort of information should be captured and built back into future projects, not only within a client, but then in the industry. It identifies and allocates responsibility to the best risk owner, as mentioned. There are several other benefits. It improves corporate experience and general communication. Helps distinguish between good luck, good management, and bad luck and bad management. Typically, in simple terms, risk management is ensuring that people are doing their job properly and thinking forward rather than head in the sand. So that's where that comment comes from. It's not rocket science, risk management, but it's around how you facilitate and challenge bias, challenge scope, and challenge, is it the right way that we are doing things, and is it the right way to mitigate things. It focuses project management attention on the real and most important issues. So as I said, ability to influence rather than weather risk, say for example, and facilitates greater risk taking, thus increasing the benefits gained. Key point there is that risk management is not about purely avoiding risk, it's about taking the right decisions to mitigate and manage the right risks, if that makes sense. You can't mitigate all your risks on a project, I would say, or if you do, you're very, very good, but it's focusing attention on what are the key ones that we can manage and we can reduce. That's always the point. And then the last image is just something from the PMI's pulse of the profession. So organisations that always use risk management practices, this isn't strictly infrastructure, it's more just general benefits, but you can see there is a stepped improvement, not earth-shattering, so to speak, but there is a stepped improvement in terms of meeting those that have used risk management practices compared to those that don't, meeting original business goals, finishing on time, and then finishing within budget. And that is me done. I will quickly try and answer the questions. Let's go with in your experience, particularly for infrastructure projects, can you recommend any risk severity assessment matrix used to rate, rank, and prioritise the risks identified for the project and then referred to in the regular? So typically, probability impact on the basis of cost and schedule is key as a priority. I would always look at adding in showstoppers and influence, the ability to influence. It flags to management what are the key risks, because you can find within probability and impact that certain risks rise to the top when they probably aren't that important. In terms of, I'm not quite sure, there are several types available, Primavera, Safran. So if you're talking around recommending tools, I'm open. In past experience, I've used the majority of tools. Primavera risk analysis is probably, at the moment, the market leader. Safran is soon to challenge, but Primavera, because of its ties to P6, as a solid infrastructure planning tool, tends to be the tool that's used. The likes of Safran are building on that, but are slightly behind the curve in terms of PRA. In terms of how do you ensure that key stakeholders are engaged in risk management and not treat it as tick box exercise? Very good question. Again, it goes back to drivers. What are their key drivers? So again, on on a current project, we have a whole host of key stakeholders, from program and portfolio stakeholders to actually external operation stakeholders. The key then is either within risk reviews, risk reports, even risk communications, that they are tailored to these stakeholders. If you're in these reviews, what I encourage is to not quite stoke the fire, poke the bear type thing, but try and go into these reviews or in these reports with something that will catch their attention. Don't just run through a risk list that has nothing to do with it. Make sure that, say for example, if operations are involved, that you're talking around risks to what's the impact going to be on their operations. Are they going to have to shut down? Are they going to have to give you certain resources or take resources off their operations to support the project delivery? That sort of thing gets stakeholders more bought into the process, or at least triggers them to have a buy-in. Hope that answered you. Yeah. Yeah. I can't quite answer that one around the Trump risk scenario. We're battling with similar stuff in the UK at the moment around Brexit, but where it's being held out with project space in terms of the impact. It's been held at client or enterprise level space, and it's for a definitive answer, it's very difficult. But what we're trying to do is run scenarios, i.e. Brexit happens and there's no impact, or there's minimal impact, or Brexit happens and there's significant impact and labour resources have to leave, material prices go up. What we're then doing is then showing this analysis to clients and giving them the range of scenarios and then trying to inform better decisions through. It's not a single point. It cannot, in terms of unknown unknowns, it can't be a single point analysis. It's better to provide a range, maybe not worst case, best case, but somewhere in between, and then enable or have those informed decisions to enable decisions to be made going forward. And then the last question, I think, is what software package do you recommend to store and model risk? I'm not I'll go past experience rather than recommendation, but in terms of Active Risk Manager and Exactium are current tools that are out in the market in terms of storing risks, so to speak. This enables management to see across multiple projects or work streams what the key risks are and roll up to see if there are common risks that can be mitigated and managed. In terms of the modelling capability of those software, they're not quite there compared to the at-risks and the PRAs. They give more robust modelling, so typically within an infrastructure project we are storing, let's say, or managing and monitoring risks within risk database and then extracting them, or the key risks that need to be modelled into these modelling software. So at the moment I am not seeing a standalone software that ticks all the boxes. We are seeing more and more Tableau, Power BI type applications being built on top of Excel that provides the kind of database snapshot dashboard that then could then be built into at-risk. So I guess maybe that is potentially an option going forward, but as I said, it's still a little bit fragmented in terms of an off-the-shelf package that does all singing, all dancing. The next question, can you elaborate on monetizing and merging the QSRA output, e.g. P90, with the cost risk analysis, apart from applying them to contract terms, penalties, LDs, and project extension cost? So typically, I would run a QSRA output, and I guess as you've mentioned there in terms of contract term, penalties, LDs, would potentially segment it up rather than one whole project. So you would look at certain stages of the project, run the QSRA, So you've done your DU, your duration uncertainty, sorry, you've mapped your risks, you've then got a range of confidence. So say, for example, procurement of a key item, or procurement of all long lead items was due end of October, let's say, and the model said P50 was middle of November, and P90 is the question asked here is end of November. What you would then do would take that delay of a month, and monetize that in terms of. So I guess picking up on your example there, if there are any penalties and LDs for not placing that contract at that time, then you would potentially model that in a 3-point scenario. So that would potentially be built into the maximum impact. So if you were to, I'm just going completely off the cuff here, but if you were to build up the maximum impact of that risk or not placing that all the long lead items, the maximum impact could be LDs as well as the additional resource required to place that procurement in that month. So you'd have the resource cost plus the LDs as your maximum impact. Your most likely impact might be just the resourcing for that month, and then the minimum would be somewhere towards either minimal impact or, say, for example, the P50 number. You may want to model that cost. That cost would then go into the cost model and then be built as 100% risk to be modelled as part of. So that then monetizes it and then runs into the cost model. I've just been informed, unfortunately, that I have 2 minutes left. So apologies if the questions were either not answered or hastily answered. I think we can capture the questions and get back to you if you have any questions. But thank you for your time. I hope it was useful, and please provide any feedback. Thank you very much, and have a good day.